In this module, I want to talk about test the hypothesis. Somewhere in your past, you've learned this topic, and you may do it like I want you to do it. You may do some things differently. There's not really right or wrong. There's just a couple different options we have, and I want to make sure everybody is on the same page. So here's what we're going to do. Let's talk briefly about why we look at test hypothesis, what it is, and then I'm going to break what I'll call the four steps or the four components of a test hypothesis down, and we'll look at them individually and talk about what we do in each step, what you're responsible for, where we get the information, and all those kinds of things. So first, let's talk about why we're doing this. We're coming out of a confidence interval environment where we're estimating a parameter. And what we saw when we're estimating parameters is sometimes the reason we're doing that is because people have questions. People want to learn information, but they specifically have some questions. And sometimes those questions involve a single point of interest. So if folks are working with the average GPA of students, perhaps somebody's interested in whether that average exceeds 3.00 or is less than 3.25, or maybe they want to compare the average GPA this semester to the average GPA 10 semesters ago or 2 semesters ago or whatever it happens to be. But sometimes there's specific questions that need answering. Let me give you some examples. I want to show that the average parking time exceeds 5 minutes. Well, if we were working with a confidence interval, I'd say go out there and estimate mu for me. But in a test hypothesis, I'm going to say, let's see if we can say that mu exceeds 5. And so we have still the parameters that we were working with the confidence intervals. We just have a couple additional pieces, a direction that we're testing and a specific value. I want to show that fewer than 25% of all college students have at least one tattoo. An article I read years ago told me it was 25%. Maybe I want to show that proportion, that's a symbol we're going to use for a population proportion. And again, at confidence intervals, I could say go and estimate a population proportion. Maybe I want to show that that probability, that proportion is less than 0.25. And so here again, we have a parameter, we have a value, we have a direction. And then the last example I'll give you here, it's not limited to just a single mean or a single proportion. I want to show that the average SAT scores of current college seniors exceed. So the way I could do this is mu1 minus mu2 is, or let's say it this way, mu1 is greater than mu2. The mean from the current group exceeds the mean from 2010. Or I might do it this way, the mean of the current group minus the mean of the group from 2010 is, let's see, the current mean exceeds, so I'd say is greater than 0. Okay, a couple different ways. I don't know how you looked at it in the past, but they're equivalent. These two things are exactly the same. And so we want to be able to specify statements like this in order to state the information that we are wanting to say. And again, when we do anything in this class, if we're trying to make statements about populations, we want to do it with a measure of reliability. Now, this is hypothesis testing. I'm going to talk about hypothesis testing being made up of or comprised of 4 different steps. And the first step is to actually formulate the test or identify what it is you're trying to do. And that last page, those examples that I went through, do a pretty good job of showing you what they look like. Well, let's take a couple minutes at least and talk specifically about what we're trying to accomplish. First thing, actually, before the first thing, so 0th thing, I don't know how you would say it. Anyway, before I get to the first thing, let me say this about test the hypothesis. There's a lot of terminology. There's a lot of symbols. There's a lot of just, the technical name I give to it is there's a lot of crap. There's a lot of stuff you got to wade through to get to the gist of the test hypothesis. Now, please hear this very clearly. This technique's pretty straightforward. It's not going to look that way. As I go through these next several videos and talk about the test hypothesis in the 4 steps, it's going to look pretty complicated, especially if you haven't seen it in a while. But trust me when I tell you, it's a fairly straightforward technique. And we're going to get through the stuff. We're going to get through all the crud and all the crap and all the terminology and all the symbols. And as we start doing test the hypothesis, if you're not there in the beginning, hopefully you'll reach a point where you just say something clever like, oh, is that all that we need there? Is that all there is to it? And by and large, the answer to that question is yes. Now there's a framework that we have to look in, and I'm going to go through that in these videos. And then as we start looking at specific examples of a test of hypothesis, as we go and look at a single mean or compare two proportions or do the things we're going to do with this test of hypothesis, hopefully you're going to get into a rhythm and you're going to get into, and I talk about doing the four-step dance. Doing a test hypothesis, it's a four-step dance. The first step, and that's the one I want to cover in this video, is identifying the test. What is it we're trying to do? And we use what are called statistical hypotheses. Again, symbols, or not symbols, but terminology. Statements about the value of a parameter. That preceding page, we said mu is greater than 5, p is less than 0.25. Those are statements about the value of a parameter. And a test of hypothesis is specifically made up of, and I'll put two of them down here, two hypotheses. We call them the null, and the symbol is HO. And I'm going to say that's the hypothesis we hope to show is not true. But start by assuming it's true. We'll hold on to that for a second. The alternative, HA, is the hypothesis we hope to show is true. All right, so you got these two, and we want to think about them as being competing hypotheses. Typically, we write the null first. I've listed it first. We write it first, and then we write the alternative. But typically, we think of the alternative first. Those statements on the preceding page. We want to show that the average parking time of all college students exceeds 5 minutes. That's what somebody wants. Hey, they'll come to me and say, hey, can we say this? Look at the data I have. Are we able to make this statement that the average parking time of all college students exceeds 5 minutes? Can we say the proportion of all college students that have at least one tattoo is less than 25%? Those are the questions people have. Naturally, the questions fall into the alternative hypothesis. And so what we need to do, what you need to do, is identify the three pieces in that alternative. You have to identify the parameter we're working with. You have to identify what we're trying to say about it. And for a lot of test hypotheses, and we're going to expand beyond that beyond this semester, but probably what you've seen in the past, all of them have a similar look. The look that we have with our test hypothesis looks like this. There's a parameter that's either not equal to, greater than, or less than. Words like exceeds, is bigger than, is greater than. Words like is below, is less than. Words like differs from, not equal to. We're going to get these different directions from the words that we're given. In the examples I just gave you, see exceeds, fewer than, we see exceeds again. So you can see that the wording is going to matter, and that's what you need to figure out. You need to look through and get proficient at picking those words out. It's not an overly difficult task, honestly, but it does take a little practice. And the parameter, right now I've talked about means and proportions. We're going to get to regression, slopes, and some other things this semester. And as I mentioned, these nulls and alternatives will expand, but typically what we're trying to say is what we write in the alternative. And a lot of times it looks just like this. The null hypothesis typically gets an equal sign, and it doesn't matter which of the alternatives you're using, not equal to, greater than, less than. There's an internal discussion among statisticians. If I have a less than sign in the alternative, is this equal to, or is it greater than or equal to? And it's a very academic discussion, which has some merit. I'll give it some merit, but overall, it's really it takes the focus off the big picture and focuses on some of the details and runs students into problems. And so I'm just going to show you the equal to sign whenever we have the null hypothesis. When we look at printouts later on, you're going to see an equal to in the null hypothesis. And so we're going to try to make it consistent and make it easier for you. That's not a bad thing. It's not a bad goal, right? To make that part easier for you. The bottom line is you got to identify this guy. Now, the way that the test hypothesis is set up, we're going to try to say, our hope is to say that the alternative is true, but we begin by assuming the null hypothesis is true. Somewhere in your past, and for me, I remember a geometry class many, many years ago, but I remember doing something called mathematical proofs. Mathematical proofs. And as I said that, you probably wanted to throw up a little bit, because most people, when they think back to mathematical proofs, it's not their favorite high school or maybe college experience. It's probably something it's like, ugh. And I think you know what I mean when I did that. But here's what I remember about proofs. I was a math guy, so proofs were, while not my favorite part of math, they were definitely a part of it and tolerable. I remember there was just some techniques we used. And the one technique that really stands out that it applies here with the test hypothesis is we used to have something called proofs by contradiction. Proofs by contradiction. And the idea was if we wanted to say this was true, we started by assuming the opposite. And if you start by assuming the opposite, you see where that takes you. And you say, well, if I assume the opposite, then this happens and that happens. And you kind of walk down this path of, well, if that's true, then this must happen. And eventually you reach a contradiction. And you say, well, wait a second, that can't happen. And you go back up to the top and you say something clever like, therefore, the hypothesis we assume true is wrong. And that's what we do here. We want to say the alternative is true. We begin by saying, or by assuming, the null is true. If we have an alternative that is the mu is greater than 5, we're going to start by assuming the mean is equal to 5. And you might be thinking, so what? Well, we know a little bit about sampling distributions. We know that if we take a large sample, the sampling distribution of x bar is going to be approximately normal. It's going to be centered at 5, and its standard deviation is going to be sigma over the square root of n. We know, and here's the whole key with this, if we assume the null is true, we know what to expect. Why is that important? Because when we go and take a sample, we can look at the sample to see if what we expected is actually what we're seeing. If the sample contradicts what we expect, there's that contradiction. That's when we're going to have this big aha moment and say, well, based on the information contained in the sample, we don't believe the null, and we're going to say something clever like reject the null. Now, I'm kind of laying out a path for you, but that's how it's done. All right, that's the test. Now, there's an ugly page of notes. An ugly page of notes I don't really want to talk about, but I need to. And so I'm going to do it in this video, and then we'll come back with the second, third, and fourth steps later. All right, so let's go to this next page of notes. The null, and just summarize. This is identifying the test, being able to say something like the null hypothesis is the means equal to 5. The alternative hypothesis is the mean greater than 5. That's what you're responsible for. And you're always responsible for that. This one's always on you. Because this one, as we're going to see, shows us where to go in the computer to do some of the work that needs to be done. Okay, so identifying the test or formulating the test, that's on you. All right, ugly page of notes. Ready? Conclusion consequences for a test hypothesis. Blah, there it is. All right, so what is this? All right, let's go back to the beginning. There's a population and there's a sample. We get the difference between them. The population is all, sample is some. We want to learn about parameters, population parameters. We want to learn about mu, for instance, in that last example, or p, the proportion of students that have a tattoo. And we want to learn about the proportion of all, or the mean of all. And so we set up the null and the alternative. And let me just come up here and write the null is, mu equal to 5. That's supposed to be colons. It didn't come out so hot. Mu is equal to 5. That's either true or false. I'm not sure. And I'm not going to know for sure because I'm not willing to sample everything in the population. If I sampled everything in the population and found the average, I would know if the null is true or not. And so the true state of nature, reality, is that the null is either true or the null is false. There's no other possibilities. It's either true or it's false. But at the end of this test hypothesis, I'm going to be asked to make a statement about the null. The fourth step, we talk about the four-step dance. The fourth step is make a conclusion. And I need to either tell you that I believe the null, in other words, I accept it, or I reject the null. That's the conclusion we're going to make. Reject or accept. And some of you may remember another conclusion. I'll get to that. Okay, reject or accept are the two conclusions I want to talk about right now. Well, if the null hypothesis is really true, if that's the reality, I would want to accept it. And I say that's okay. That's a good decision. If the null hypothesis is really false and you ask me what I want to do with the null, I would like to reject it. That would be a correct decision to make or conclusion to make. That's what I would like to see happen. One of those two things. I want to make good information, good statements. I want to make true statements. So I want to make good decisions. Now these other two possibilities, if the null hypothesis is true and we reject it, we call that, here's some of that crappy terminology, a type 1 error. And if the null hypothesis is false and we accept the null, that's called a type 2 error. Yuck. Both are bad. In fact, let me show you something. We put probabilities attached to them, alpha and beta. Now, if you're into formulas, you might have seen this alpha before. When we go into our confidence intervals, a lot of times we talk about working with tail probabilities, probabilities of making mistakes, of alpha over 2. And so those two tail probabilities sum up to alpha. So when you say you're 95% confident, your alpha is 5%. If you say you're 90% confident, your alpha is 10%. So we've met, sort of. I don't make you do a lot of the math, but that's where we've seen it. The alpha is the opposite of the reliability. Okay, alpha is the probability of this guy, beta is the probability of that guy. Well, they're both errors. They're both bad. We want alpha and beta to both be small. We'd like them both at 0.05. It'd be great. Unfortunately, they are inversely, maybe that's something you want to write in your notes, they're inversely related. What's that mean? It's a math term. Well, it means if I make alpha small, beta is going to get big. If I make alpha smaller, beta is going to get bigger. And if I make beta small, alpha is going to get big. I can't make them both small at the same time. There's no exact relationship. It's not like alpha plus beta have to equal anything. I know if alpha is 0.05, I say, oh, you know what? I really want to make it 0.04. I know beta is going to get big. It may be by 0.01. It may be by 0.7. I don't know. And that's one of the frustrating things about these errors. They don't have an exact relationship. I just know when one is small, the other one is unknown. That's how you have to think about it. You can specify one of these things, and the other one is unknown. So here's where we're at. We said we want to say the alternative is true, right? That's our goal. Which of these two conclusions says the alternative is true? That one. The way that we say we believe the alternative is true is by rejecting the null hypothesis. We're actually going to say something like there's sufficient evidence to indicate that the alternative is true. That's going to be some of the wording we use with the reject H0 conclusion. So if we want to say the alternative is true, which we stated up front, very first thing I said was we want to say the alternative is true. We begin by assuming the null is true. Well, the way that we get there is by rejecting H0. So if that's what we want to do, that's where I want my reliability. I want to know the chance of me being right, because if I reject H0, there's only two possibilities. There's either a type 1 error or a good decision. I want to know the chance of me being right and the chance of me being wrong. So we specify alpha in a test of hypothesis. What that means is we don't know the value of beta. That's going to be a problem when we go to accept, because the chance of us being wrong, that's beta. And what we're saying is by choosing alpha, we don't know what that is. I'll talk more about that idea when I talk about the conclusion in step 5. So this page of notes, this is, I sometimes in my Stat 1 classes, I talk about this being the single worst page of notes I'm going to give you all semester. I'm trying to think this semester. It's up there. It's in the running. It's bad. There's lots of stuff there. Now, the advantage I have is you've seen this before. Some of you guys remember pieces of it. Some of you don't remember much at all. And that's okay. It's stuff to think about. It's going to be my reasoning, my rationale later for telling you why our two conclusions are going to be either reject, got the chance of alpha of being wrong, and then our other decision we're afraid to accept because of the unknown beta here, and we go to fail to reject. But hang in here for a couple videos and I'll talk a little bit more about that. Hopefully specifying the nulls, tell me what the null hypothesis is. Mu's equal to 5 versus the alternative, mu's greater than 5. P's equal to 0.25, P's less than 0.25. Being able to tell me what those hypotheses are, that's your goal in step 1. Good luck.